So please welcome Justin. I'll let him introduce himself. Really excited about his talk on modern Python packaging with UV. This should be good.
Great. Thanks, Dan. Yeah, like Dan said, my name is Justin Smethers, and I'm going to be talking about modern Python packaging with UV. UV is the particular Python packaging tool I'll be using, but there are many, many others, as I'll get into later in the talk. And I call it modern Python packaging because UV is one of a few tools that kind of streamline the process a little bit. Again, as we get into it, we'll see kind of a lot of different ways to go about it and different levels of complexity involved with those different tools. On the right here, I have pictures of two different things. Bottom right is the UV logo, so that's just UV. Top right is the Python package index logo. So that's where packages are generally uploaded to. That is the central repository for most Python packages. So we'll talk a bit about that as we get into this as well. First, just a quick further introduction. I'm an analytics engineer at Brooklyn Data Co. As I mentioned, a data consultancy. Use Python at work, but also just learning on the side. I've been reading Fluent Python, so if anyone wants to talk about that, I'm down. But yeah, let's get into it. So, an outline. So, as we get into this, at a high level first, I wanted to do this talk to kind of force myself to learn more about packaging. It was something I'd kind of been putting off in Python, and it's something you can get away without using for a long time. But I think it's very important for several reasons, and I'll kind of outline those as we go into it. But this will be kind of an exploration into me learning packaging and hopefully demystifying the process for others as well. Because with all those different tools that I'll mention, it's kind of confusing. And as I learned, I did find it confusing. Um, but so specifically, this talk will go through what is packaging publishing more at definition level, why package and publish. We'll go through a demo of publishing just a small project with UV, and we'll glance at other publishing tools. But again, there's kind of a lot to get into there. So let's get started. So what is packaging and publishing? Packaging is just wrapping scripts or modules in metadata. So that's the name, version, dependencies, license, description. So really, it's just adding that to whatever script you're already working with. And those get packaged up so it can be distributed on something like the Python package index. These metadata are usually added in a pyproject.toml file, and we'll go through that in the demo where we show kind of how you list out the name, version, dependencies, etc. This outputs two different files, wheel file, which is the build distribution, which is what actually gets built when you pip install a file, and another file, which is the bundled source code of the package itself. And I'll point these out when we get to the demo as well. That's the packaging side of things. What is publishing? That is just uploading the package distribution. So when you actually build it, you get those two output files that I just showed there, and then through a command with UV, which is just UV publish, is just uploading it to something like the Python package index. There's also other registries. So there's private registries that companies host themselves. There's different places. I know Anaconda has something. Maybe Dan can speak to that. um, but we'll be looking at the Python package index because that's where the bulk of packages are kind of used. In a quick tangent, didn't have it on the content, but for those that are familiar with registries, I just thought this was an interesting note. UV is built by a company called Astral, and they're currently beta testing their own private registry, paid private registry. Just kind of a cool idea, I think, that they're trying to solve different problems with Python packaging, where people often have difficulty managing different versions of packages, especially things like machine learning packages like PyTorch or CUDA, or having to rebuild the same packages over and over again. And this uh, PyX is their attempt to kind of vertically integrate UV in a package registry to solve those different things. So outside of the scope of this talk, I just thought it was interesting and worth mentioning since I was diving into packaging with UV. But if you're interested, this is the blog where they talk about it if you just Google introducing PyX. So why package and why publish? Uh, Really, it's to turn scripts into usable tools. This ultimately, my idea to want to do a talk on this was started by trying to share a script with a coworker because I had started with messing with utility scripts with Obsidian, a note-taking app. Um, and in doing that, I was like pushing a repository to GitHub, adding him to the repo because it was a private repository, and then having him clone and run the repository himself. When he showed me, you can just package it. So it's just a way to much more easily reuse and collaborate on code because once someone can just do a pip install of your package, it's much easier to use. This also leads to reproducibility, where if they're downloading your package in your code, they don't have to deal with the same, requirements file. It's kind of just built into the distribution. And also for visibility for yourself, I think it can make good portfolio projects. If you have something that can run, just on a pip install, I think that can look good in a portfolio, and especially in the age of, AI loosening the bottleneck from instead of writing code is the bottleneck, it's getting working things. I think turning those into packages and distributing them that way can be a good way to show off, the ability to create projects. So from here, we'll look at a demo, and I think that will kind of show off the process of actually doing this. So we're going to take a script, initialize a package, and we'll see what are the differences there. We'll edit the metadata, as I mentioned earlier, so the name, description, all those different things, and then we'll publish it and see what that looks like. So let me jump over here. I'm going to pull up my VS Code where I have a sample project here. Once I get that, lost my mouse. Sorry, having trouble getting my VS Code to go on the screen. Projectors are hard. Yes. It was showing up there?
Yeah.
Weird. Okay, let me try exiting the slideshow maybe. There we go. Okay. Slideshows are hard. Let me get my doc out of there. Okay, sorry. Okay, so finally we have just a very simple script here. This is just printing hello Michigan Python. I think, if you're familiar with Python at all, you should kind of understand we're defining a main function here, which when run will just print hello Michigan Python. This arrow here is just saying that the function isn't actually outputting anything for anyone that is unfamiliar with that syntax. As you can see, this folder is just this file. It's just named cli.py and nothing else. So to actually turn that into a package, we open the terminal here, and I have already previewed the command here. We're using UV to initialize a package named Hello Michigan Python. So once we do that, UV takes care of a lot of the scaffolding of the project here. So these are different things that are required to distribute the project. So as I mentioned before, the pyproject.toml has the different metadata fields. So we have the name of the project. So if you were to upload this, you would do pip install hello Michigan Python would be the result of this. You have a version, so the version number of the package itself. You have a README, which is just automatically created when you initialize the project here. Author information, which is just myself, requires Python, any dependencies, which we haven't added any, and a couple different things down here that are specific to building a package. So I'll spend a little bit of time on these as well. There's kind of two different things going on here. First, this project.scripts. This is a configuration in the metadata that's telling the package where to actually run the main function. So it's going to look in Hello Michigan Python, which is the folder that it's within, and it's going to look for it's going to execute a main function. That is stored inside this source file. So this is actually the package name that it's or the folder name that it's looking for, and it's going to look in this init function here. right now it's a bit redundant. It initialized an init.py file, which already says hello from Hello Michigan Python. So that's all this line is doing here, saying look in the Hello Michigan Python folder within the source folder and run the main function. The build system here, this is a separate thing. So this is how the package itself gets built. So this is going back to um, this, what is a package and what is packaging. This is what's actually building these files here. So the build system itself is just this build backend. There are a bunch of different ones of these. UV comes with UV build as the default, but there are all different ones that effectively do the same thing. I think they have different features and different levels of, I guess, different customization and different things you can do with them. But as far as getting started, using the default works just fine. So we don't actually have to mess with this just to get started. Um, So from here, I'm actually going to make some changes. So I'm going to take that original file that just prints Hello Michigan Python and put it into our source folder. So again, this source folder and this Hello Michigan Python folder are where the code is actually looking for um, the different scripts to run when you execute the package. And we're going to make a change to this init.py. So the CLI.py is theoretically where we want to do the actual, where we want to have the actual code, where we want to actually do processing. So this could be as complex as you want it. Instead of having init.py take care of that, we're just going to import, or not import, from CLI, yeah, from .cli import main. So instead of doing that in the init.py, it's instead going to do the printing in this file, and init.py is going to import that function here. So it's going to do a function just the same as kind of what we went through here, but just moving the logic into a different file for kind of cleanliness sake. So from here we have basically all the scaffolding we need to actually build a project. So how do you go from here to a project? UV has some commands to actually do that. So UV streamlines it a lot where you just have to run UV build. Oop, what is? Oh, I'm in the wrong directory. Now I'm actually in the project folder. I was one folder above before. So that step, as I said, is just going to produce those distribution files. So you have the wheel file, which is again how the project gets built, and this package source code. So these are what actually get uploaded when you publish, which is also a simple UV publish. Now, this command would publish to the Python package index, so that PyPI. Um, Instead, just so I'm not uploading a hello py file, we're going to upload it to a test URL. So PyPI has this test URL that instead of going to like the big public index, it's just a way to like sandbox and play with different packages. So I added these different flags here. So this token is just an API token to actually connect to my account, and this publish URL is where it's actually going. So it's just going to upload those. Now, theoretically, these should be uploaded to my test PyPI projects. There we go. So this is the Python package index. This is the test URL specifically. And within my account, you can see I published just that hello Michigan Python. These are also my demos as I was trying to figure this out. um, excuse me. Now, also theoretically with these here, you should be able to pip install uh, hello Michigan Python. I couldn't for the life of me figure out how to actually install this from the test test PyPI. So I couldn't get this to work. So instead, we're going to demonstrate this with a slightly different route, which also should kind of show the use of these distribution files. Instead of doing pip install just the name of the package, we can install it directly from these files here. So I have the distribution files, and I can pip install directly from that wheel file, which this is what is actually doing when you do a pip install pandas, pip install any particular package. It will, oh, I don't actually have pip install. I have UV pip installed. Ah, right, I'm not in a virtual environment. Okay, so now that I have a virtual environment installed, which UV named Hello Michigan Python, now I can do UV pip install and install from the build file. Oh, distribution not found. Um, I'm not sure why that error is. I have a different working one here that might instead work. Okay, instead I'm going to do it in this one that I just had working because I'm not sure what happened there, but um, this is the same process here. So I'm in a different folder now. So I would do dist. Right. Oh, I missed install. Sorry. Okay, uh, so this is actually pip installing directly from the wheel file. So that is installing that into the virtual environment here. This is a different folder, so it's a different name. Instead of Hello Michigan Python, this was the testing print that you might have seen in my test PyPI instead. But now that that's installed, testing print, not bring. Now that it's installed, I can run it just like a package that's there. So again, this is what's happening when you're pip installing something, it's pulling it down and it's making it executable. So this is again why it's also shareable. So if this were actually uploaded onto PyPI, you could have a friend, coworker, whoever, just do UV pip install testing print, and this would be on their machine just the same here. So that's more or less the process. Really simple enough to actually get this packaged and published that way. This showed kind of installing it locally instead of installing it from PyPI, but more or less um, that's the process for actually creating this. Now you can imagine you're not going to be just um, printing Hello Michigan Python. So within this source folder, you can add any number of different files and do all sorts of different application code within here. And this is the same process, just scaled up from there. So going back to the slides. Oops. Sorry, I lost my presentation now. Okay, so yeah, again, that's sort of the very simple process of just taking a script, initializing a package, editing the metadata. So we could have added a description or renamed the package to something else and publishing it using UV publish. I wanted to shout out as well uh, kind of the different tools to use this. So like I said, UV is just one particular or one way to actually um, one way to package and publish projects within Python. But as I was reading, as I mentioned kind of at the top, one of the things that was kind of mystifying about packaging is just how many different ways to do it. And in researching for this project, I found this blog that was interesting. That's how to improve Python packaging, or why 14 tools are at least 12 too many. There are just a significant amount of tools that you can use to achieve essentially the same thing. And I think this one doesn't list, where is it at? Oh, sorry, I lost my list here as well. Here we go. So this is a sampling of a list of the different tools that can essentially achieve the same thing of just packaging projects in different ways. Several of them function very similar to UV. Some that I'll call out are Hatch is a tool that's for managing the entire life cycle of project creation, versioning, building, environment management, and publishing, which is very similar to the process we just saw with UV. Um, PDM is another. Pip tools is one of the, I suppose, I don't want to say legacy, but just less streamlined ways of doing it. And say poetry is another kind of end-to-end one. But as you can see, just lots of different ways to actually achieve this. So yeah,
If you have a library that's a binary, what I don't know, what step in the process is figuring out which binary is right for your system? Is pip doing it locally, or is PyPI somehow doing it? Like there's a Postgres binary that I install with every single new project I create. And that's it seems magical. So do you know anything about how that works?
I read a little bit about this. I think it's done on the Python package index, and I think there's some sort of best guess system going on. I think that's what leads to issues, as I mentioned a little bit with the PYX project, where like the reason why there's so many issues installing things like PyTorch is the binaries don't match like the system hardware. So I think PyPI can only make kind of an informed guess on that, where the vision of like the PYX is it can integrate with your local UV and kind of solve that mismatch problem. So typically done as best guess, but this is a new tool that's attempting to solve that. But yeah. Uh, yeah, I guess other questions. I think kind of to wrap up, I think that was more or less the demo I wanted to show. Like I say, as I was kind of learning this, I found this to be sort of a confusing process of mainly running into all these different projects that make the process, hard to grasp which exact tools are needed, which exact steps uh, go with which different tools. So I wish I could have fleshed out the demo a little bit more, but the simple demo I think shows kind of the general flow. So any questions?
So when you use UV to upload it to PyPI, when someone wants to download your package from there, do they have to use UV, or does PyPI make it so you can just use pip or any normal or any of these
Yes,
to package
PyPI
it?
PyPI makes it so you can use any sort of package, and PyPI is kind of the default package index. So, as an example, UV is open source, and this is UV's page on PyPI. But there's all sorts of different ones here. So, if you were to go, so yeah, this is just a landing page. But when you do pip install UV or pip install pandas, it'll pull that down from here. So you can use different tools to actually install the package once it's on PyPI. Um, all different ones. I pulled up Cause as just another example of, within the PyPI page itself, it has links to the like the release history. These are like the different updates. So every time you were to publish a package with a new version number, it comes here. It can link to the actual code. Is that on this one? Maybe not. But like UV has a link to the GitHub where again it's open source, so it has the code directly in the PyPI page. But yeah, once it's in here, anyone can just pip install or use other tools to install it otherwise.
Hey, thank you. Talk really good. I think you'd be surprised to see there's a tool called UVX that allows you to run directly from GitHub, pulling all the dependencies, which is an extension to UV.
Yes. Yeah. UVX is a different, like an alias of a command in UV.
They-
It's
Yeah, the distributor has a separate binary, or you can use a UV with some flag. I don't remember it on top of my mind. But basically, what does installs the from GitHub package and then runs it, so you don't need to literally can pass to the user just a command line and we run remotely.
yes. Yeah. That is it's sort of a analog to pipx. Oops, I have caps lock on. Pipx, which is just another way to run those tools. Yeah. UVX is a
Yeah.
way to download those without having to install them on your machine. So, for example, with UVX, you can run Cause, the tool I just showed on PyPI, and it will install and execute it, which, if you don't know, Cause just outputs this cow saying whatever you type in. Uh, and this isn't actually installed when you run UVX, so I can't actually do Cause text hello because it's not actually installed. You could do UV tool install Cause and then run it just the way I did. So just to show off kind of what Antonio was showing there with was mentioning there with UVX running the binary without installing it, and just showing UV tool install as a way to actually install that binary.
Piggyback on Dan's question about the binaries. I believe UV use the same backend as a PEEP for binaries, so we use the same logic. And the binaries in PyPI are mostly built using many Linux, which is different from Conda that has its own entire stack. Um, it's basically a philosophy difference between PIP and Conda. Conda builds everything from the same source tree, more or less. PIP instead uses man Linux, that's a Docker image to build the binaries, hopefully matching whatever is your runtime environment, especially on Linux. Yeah, it's big. So, and I don't know exact. I'm not sure about the UV package. Sorry, builder. When I never use it. More familiar with Hatchling. But in case of Python packages, usually you need to use a setup tools for building binaries. If you have a code that is written, let's say in C or C++. Hmm?
Like the build backend, you mean?
Yes, exactly. You show some at some point in pyproject.toml, UV tool, I think is called.
I think I had somewhere here a list of the different.
Yeah, there's a boatload of them, unfortunately. If you open your own
Yeah,
PyProject the issue is yeah, build backend. Hatchling is considered like the standard. And okay, setup tools is the one if you have a binaries that depend on C or C++ code to be built. But pip wheels are built using Salt or many Linux.
All right, thanks, Antonio. We also had another question here in the room.
I firstly thanks for the talk. Um, so my question was, does UV provide any sort of version management control or something like that in which we can track what versions for the packages which we are pushing onto the PyPI repository?
As in the version management of what you're publishing or what
Right.
you're.
Yeah.
Yes, um I know there are commands. So I think kind of two ways to go about it. I think you can kind of manually iterate your version here. So this is just,
Okay.
each time you publish, you could iterate it in whatever way you as the package manager would want to. So
Right.
you might do like version 1.1 or version 1.0a. Yes, UV does have commands to actually iterate. Let me find what that is. I'll have to find it. But yeah, there is a way that just a like one line command that would iterate it by 0.0.1. But yeah.
Also, Andy had a question in chat. He was asking how to promises made by UV compared to other package management tools in the space like Conda.
I think I'm uh unfamiliar with that, unfortunately. I think I this was more my foray into learning package managers and building packages at all. So it's a nuance I have yet to dig into.
Uh, so I am the engineering manager for Conda, but maybe we could talk about it after the meeting. Any other questions for Justin? Justin, are you willing to try something?
Yeah.
If you pass in dash dash index, I think you can install from your test PyPI if you want to give it another go.
Let's see.
So if you do like UV pip install, then dash dash index, and then https test.pypi.org.
Right.
Hopefully this will work. I'm asking Justin to try something live. So https://test.pypi.org/simple
Right.
and then space. What was your package called? Michigan, your simple hello or hello Michigan Python.
Oh, there we go.
Did it.
Wow.
Yeah, so if you are using like an alternative index, that's how you tell UV about it. You pass in it as an index like that.
Gotcha. That makes sense. As soon as you say that, I remember seeing that as I was researching and
Any other questions for Justin? Thank you so much, Justin. UV is really cool project to be able to quickly install dependencies and quickly build packages and share them with others. So thanks for sharing how to get your packages out there in PyPI and share them with others. That's really good. Thanks, Justin.
thanks everyone.